In this section, I will explain what SQL injection is, describe some common examples, explain how to find and exploit various kinds of SQL injection vulnerabilities, and summarize how to prevent SQL injection. SQL injection is a web security vulnerability that allows an attacker to interfere with the queries that an application makes to its database. It generally allows an attacker to view data that they are not normally able to retrieve. This might include data belonging to other users or any other data that the application itself is able to access. In many cases, an attacker can modify or delete this data, causing persistent changes to the application's content or behavior. In some situations, an attacker can escalate a SQL injection attack to compromise the underlying server or other back-end infrastructure or perform a denial of service attack. A successful SQL injection attack can result in unauthorized access to sensitive data such as passwords, credit card details, or personal user information. Many high-profile data breaches in recent years have been the result of SQL injection attacks, leading to reputational damage and regulatory fines. In some cases, an attacker can obtain a persistent backdoor into an organization's system, leading to a long-term compromise that can go unnoticed for an extended period. How to detect SQL injection? The majority of SQL injection vulnerability can be found quickly and reliably using Burp Suite's web vulnerability scanner. SQL injection can be detected manually by using a systematic set of tests against every entry point in the application. This typically involves submitting the single quote character like this apostrophe and then looking for errors or other anomalies, submitting some SQL specific syntax that evaluates to the base original value of the entry point and to a different value, and looking for systematic differences in the resulting application responses. Also submitting Boolean conditions such as or 1 equal 1 and or 1 equal 2, and looking for differences in the application's responses. Submitting payloads designed to trigger time delays when executed within a SQL query, and looking for differences in the time taken to respond. Also submitting WAST payloads designed to trigger an out-of-band network interaction when executed within a SQL query, and monitoring for any result interactions. SQL injection in different parts of the query. And this type of SQL injection is generally well understood by experienced testers, but SQL injection vulnerabilities can in principle occur at any location within the query and within different query types. The most SQL injection vulnerabilities arise within the where clause of a select query. The most common other locations where SQL injection arises are in update statements within the updated values or the where clause, in insert statements within the inserted values, in select statements within the table or column name, in select statements within the order by clause. Here are the SQL injection examples. Depending on the types, there are a wide variety of SQL injection vulnerabilities, attacks, and the techniques which arise in different solutions. Some common examples include retrieving hiding data. It's where you can modify an SQL query to return additional results. Subverting application logic, where you can change a query to interfere within the application's logic. Union attacks, where you can retrieve data from different database tables. Blind SQL injection, where the results of a query you control are not returned in the application's responses. Let's let's try to understand retrieving hidden data. Let's consider a shopping application that displays products in different categories. When the user clicks the category gifts, their browser request will be like this: category equal to gifts. In the SQL language, it means that the select from the database products where the category gifts and release it equal to 1. It means that this causes the application to make a SQL query. This SQL query asks the database to return all details from the products table where the category is gifts and released is 1. The restriction released equal 1 is being used to hide products that are not released. For unreleased products, presumably is released equal to 0. The case thing here is that the double dash sequence is a comment indicator in SQL, and it means that the rest of the query is interpreted as a comment. This effectively removes the remainder of the query, so it no longer includes and released equal 1. This means that all products are displayed, including unreleased products. Going further, an attacker can cause the application to display all the products in any category, including categories that they do not know about. This result in the SQL query select from products where category is gifts plus or plus 1 equal to 1 and the two dashes. The modified query will return all items where either the category is gifts or 1 is equal to 1. Since 1 equal to 1 is always true, and the query will return all items. The second one is subverting application logic. Let's imagine that username is winner and the password is blue cheese.